Good evening. Theory of Computation. The subject code is 21 CS503. Myself, Sharmila, Assistant Professor, Department of Computer Science and Engineering, R.M.D.E. Engineering College. In this theory of computation, we're going to discuss initially what is finite automata. That is called as FA. FA is called as finite automata. It's a mission to recognize a pattern. It is a simplest mission to recognize the pattern. Pattern is nothing but, for example, that tiles in your home floor, like a similar pattern like checkbox in the chessboard. So that is called as pattern. The finite automata mission is having a 5 elements or a tuples. So it has a set of states. It having some rules from where to move from one state to another state. How it depends upon that input symbol. If you give the input symbol, what is happening, which we goes to which state, belongs to which state, that input symbol. Like that, we're going to discuss about the finite automata. It have how many tuples? 5 tuples. This is the features of finite automata. Input is given I1, I2, I2 up to In. That automata contains this different states. That state is represented here as Q1, Q2, Qn. And the output of that particular state is output 1, output 2, output n. Like that, they are given features of finite automata. That above that particular figure, what we have seen, it have features of automata is input, output, state of automata, state of relationship. That is state of relationship in the sense will be from which state to which state it moves, and then output relation. So here the finite automata of 5 tuples Q sigma small q f del. That capital Q is a finite set of state, that is number of state, finite number of states. And sigma is a set of input symbol. What are the input symbol we are giving in the grammar? That comes under sigma, set of input symbol. Then small q is the initial state. Initial state is nothing but the start state. F is the final state. F, capital F represent the final state. What is the final state of the automata? Del is a transition function. Transition function in the sense from which state, if you give the element A as an input, from which state to each state it moves. That rules comes under the transition function del. So here two types of finite automata. One is DFA, another one is NFA. Deterministic finite automata and non-deterministic finite automata. First, we're going to discuss about what is deterministic finite automata. In that, we have again 5 tuple Q sigma Q small q F del. Here Q is the same set of all the state number of states. Sigma is a set of input symbol which makes the input. Mission makes the input. Q is the initial state. There is a starting symbol of the mission, which is the start state. F is the final state, end state. Here the transition function del is Q sigma Q, that is tends to Q. That is a del transition function for deterministic finite automata. The example given for deterministic finite automata is the given example. The input symbol is 0 and 1. That states 0 and 1, two states here. If you give one input for the state 0, it moves to the state 1. If you give 0 input, it moves to the state 1. If in the 1 input, if you give this 1 again input for the state 1, it goes to the 0. If you give in the 1 input symbol, it goes to the 0. Input is 0 means it will be in the remains in the same state. Here the deterministic finite automata have a 5 tuples. As we discussed in the last slide, the mission goes to only one state at a time. The transition function, every input symbol have a null or epsilon mu is not allowed. In the DFA, what's the difference is null and epsilon mu is not allowed. Only one state transition only is possible. DFA cannot change the state without any input character. Without any input character, we cannot change from one state to another state. Next one is non-deterministic finite automata. Again, here the tuples are del, Q, sigma, finite automata. Only the difference is del transition. The del transition is Q, sigma union epsilon tends to 2 power Q. Here, what's the difference is it allows the null transition. If any input including null or any no symbols also means input symbol also means we can move from one state to another state. Here the NFA, if a path from an input string leads to a final state, then the input string is accepted. So for example, NFA, there is a simple path for the input string 0, 0 is given in this. It leads to the final state when 0, 0 is accepted. The given for NFA. Here that difference is only the transition. The DFA of del transition is Q into sigma tends to capital Q. Only one state at a time it will move. There is no del transition, null transition allowed. In the case of NFA, it allows the null transition, and if then Q cross sigma equal to that number of states is 2 power Q. So today's in this video, what we have discussed is what is finite automata, what are the two different finite automata. One is DFA, another one is NFA. I hope you understand the transition diagram and del transition for DFA and NFA. Thank you.